Thanks for watching this screencast. The objective of this screencast is learners will be able to, given a system of inequalities, determine the coordinates of the feasible region. Okay, what you're looking at is the graph of a system of inequalities on Desmos, on desmos.com. And we will be using this site to support our learning with this learning target, all about optimization with linear programming. One of the things that's nice about Desmos is that it is pretty easy to look at some graphs of some systems of inequalities. This system actually has 4 different inequalities. Y is less than or equal to 4. Y is less than or equal to negative x plus 6. Y is greater than or equal to 1/2 x minus 3/2. And y is less than or equal to 6x plus 4. And you can see each graph here on the graphing part of the Desmos screen. Each inequality has a different color. Actually, well, I guess the first 2 are both red. But we're going to be doing a task when we get together for the class meeting for Learning Target 9, where we are practicing using the graph of the system of inequalities to solve some problems, to do some problem solving. So what we need to look at is what we call the feasible region. The feasible region of this system of inequalities is simply the region that is solved by all of the inequalities. We called it the solution back in Learning Target 8. We're going to think of it as the feasible region in this learning target. So can you look at this graph and can you tell which part of the graph has been solved by all of these inequalities? It might be a little tough. So one of the things that I like about Desmos is over here on the left side, by each inequality, you can click on the little colored circle there to turn on and turn off the inequality. So one of the things that I do find helpful, if I can't tell exactly what that region is to turn them all off, like this, by clicking on each inequality, and then one at a time turning them back on. So here's the y is less than or equal to 4, which is, as I would have expected, the stuff below the line y equals 4. Now here comes y is less than or equal to negative x plus 6. So now I see, these are both pink. So the region that was pink, the darker pink, is solved by both of those. Here comes the next one. And now I see that adding that in there makes this region here kind of the boundary of the feasible region. The one that's both blue and pink. And let's add that last one in. There it is. Okay. So adding that last one in, this right here is our feasible region. One of the things that's nice about Desmos is that once I identify that feasible region, all I need to do to identify the points of intersection, or in other words, the vertices of these, is to find those intersections and then click with the mouse. So these 4 ordered pairs here, negative 1, negative 2, 0, 4, 2, 4, and 5, 1 are the coordinates of the vertices of that feasible region, the endpoints of that polygon. And that is our goal with this learning target, at least the first objective on this learning target. So what we'd like to do here is we'd like to try doing this by hand. Here is a system of inequalities. It says find the vertices of the feasible region. So let's think about graphing this system. I'll use different colors here today. I'll do red for y is greater than or equal to negative 2. That's going to be a solid line. That's the horizontal line, y equals 2. And if I think about shading that thing, and I would encourage you again to kind of shade lightly here, I want all of this stuff, don't I? All of the stuff above that line now. Everything in this half of the graph works. Now I want to graph the inequality y is greater than or equal to, let me get blue here, y is greater than or equal to 2x minus 4. That's going to be the line with a y-intercept at 4 and a slope of 2. like so. And I need to make that line a solid line. And I need to shade the side of the line that is above that. That's what y is greater than this would be. So that would be all of this stuff. And I can already tell you, I see part of that feasible region coming together. Do you? The part here that's shaded by both the blue and the pink. So let's do one more. Let's do that last one. And this one, of course, needs a little bit of work to graph. One way you might do that is by solving that thing for y. So if x minus 2y is greater than or equal to negative 1, if I take this x and make it a negative x over here, I've got negative 2y is greater than or equal to negative x minus 1. If I divide everything by negative 2, I'm going to have to flip my inequality sign. I've got y is less than or equal to, this would be 1/2 x. You know, negative 1 divided by negative 2 is 1/2, plus 1/2. And that's a little bit odd to graph. If I think about having a y-intercept of 1/2, if I think about going up 1 and right 2, I'd be up to 1.5, right 2. 1.5, right 2. Or down 1 and left 2 even. So I see that line going through here. And this is y is less than that. I need to shade all the things below that. So all of this stuff solves that. Okay, let's look back. We've solved the system by graphing. We found, where is the feasible region? I think it's right in here. I see a little triangle. Do you see it? This triangle is the solution to all three of those inequalities. So if I want to identify the feasible region, or excuse me, the coordinates of the vertices, I'm looking for these 3 points. Looks like one of them is here at 3, 2. Looks like another one is here at 1, negative 2. And maybe a third point over here at negative 5, negative 2. Okay, it's your turn now. Try this. See if you can make a reasonable sketch of this. Pause the video. And when you think you've got a sketch and if you've been able to identify those vertices, hit play and we'll check it out. Let's do this thing. If y is greater than or equal to 2, one of my boundary lines looks like this. And y being greater than that means that I need all of this stuff, all of the stuff above that line. All of this stuff. This is kind of an interesting next inequality because it's a compound inequality. It says that I want the x's that are both between 1 and 5. So that would look something like this, you know, to be greater than 1, but then also less than 5. Those would kind of be our boundaries for that inequality. So which x's make that true? Well, the x's that are between there. So all of this stuff in here. Right now, our feasible region looks like a rectangle, doesn't it? Yeah. And then our last one to do here says, how about y is less than or equal to x plus 3? So the boundary line will have a y-intercept of 3. It's going to have a slope of 1, so up 1, right 1. Like so. let's see. Something like that. Which side of the inequality is solved? Well, I need the y's that are less than that. So the y's that are below the line. All of this stuff. Yeah. So this is the feasible region right here. I'm going to outline it in black. So it's a trapezoid. Right there. So what are the coordinates of the vertices? Well, I've got one here. It looks like it's 5, 8. I've got one at 1, 4. I've got one at 1, 2. And I've got one over here at 5, 2. And there we have it. Thanks for watching.